2, and we're looking at lesson 5-3, which starts on the bottom of page 158 in our textbook. And it's titled Simplifying Rational Expressions. And so in simplifying rational expressions, the things that we're interested in watching for are what we can factor, and especially when we can factor something from in the numerator and the denominator that are equivalent, so that we can cancel or reduce those parts, those factors, to 1, right? So I think one of the easiest ways to approach this, I mean, you need to read carefully and understand, but one of the easiest ways to approach this is just look at some examples. And I'm just pulling these examples from the lesson, or the text on pages 158, 159. So, if I have something like this, negative 13 over 52, the negative I'm not going to worry about. I'll just let it hang out front. But the 13 over 52, what I want to think about is this reducible? If it is, I know 13 is a prime number. There's no two numbers, at least integers, multiplied together that make 13. Right? 1 and 13, but that doesn't count. So what I want to think about is 13 times something equal to 52? And what occurs to me is that 13 times 4 is equal to 32. Or it's not really. 13 times 4 is equal to 52, right? If I wanted to, I could think about the top as 13 times 1. Now what I have is this negative sign hanging out front. I have 13 over 13 times 1 over 4. And obviously you're not going to write all this out, what I'm writing here, but this is just so you can see what is happening. The 13 over 13 becomes a 1. So now you have negative 1 times 1/4, which is negative 1/4. So negative 13 over 52 simplifies or reduces to negative 1/4. But see, this can work algebraically as well. And the example given on page 159 is this: 36 times the quantity x plus 1 over 9 times the quantity x plus 1 cubed, right? Now, one of the things that can be really helpful is to go ahead and factor out as much as you can, or as much as you want at least, right? So if I start on top of this and I start factoring, like the 36, I think about, 6 times 6 is 36. That's interesting. But more interesting is the option 9 times 4. And you might think, well, why is that more interesting? Because there's a 9 in the denominator, right? And so anytime I can get factors on top and the bottom that are the same, I can cancel or reduce those to 1, right? And so then on top I have this x plus 1. So it'd be cool to have an x plus 1 on the bottom. Well, I do. An x plus 1 on the bottom is inside that x plus 1 cubed, which I can rewrite as the quantity x plus 1 times the quantity x plus 1 squared, right? So now when I look at this, and remember, these are just factors multiplied to each other, so I can split them apart on top, and then on the bottom I can write them up as this x plus 1 squared here, and then we'll do the x plus 1 here, right? Why would I do that? Well, the 9 over 9 is a 1 times 4 over x plus 1 quantity squared times the x plus 1 over the x plus 1 is a 1. So really what I have is 4 over x plus 1 squared. But then if you look in the text, you'll notice something that I haven't said anything about yet. I can't have x plus 1 equaling 0, right? So I need to write the exclusion, x not equal to 1. Right? X can be anything. It can't be 1, because then you end up with something undefined. Okay, so let's look at example 1, bottom of page 159, and let's just talk through that. We're given this problem, quantity y cubed minus 25y times the quantity 2y squared minus 11y plus 5 to the negative 1. Okay, well, this can be the kind of problem that you would look at and you would say, I don't have any idea what to do. I know I'm supposed to write it as a rational algebraic expression, as a fraction in the lowest terms, simplified, reduced. Okay, when you're dealing with just numbers, this problem is saying, reduce the fraction. Okay. Okay, so I need to make this a fraction then. Well, I see how I can do that because a negative exponent doesn't like where it is. So move it to where it will like to be. And so I'll do this. Okay. Now, the next thing is, I can look at this and say, okay, that's great, but I don't know what to do. Well, go back to the instructions. I need to write this as a rational algebraic expression, a fraction. Okay, I've got it in a fraction, in lowest terms. I need to simplify it. I need to reduce it. To reduce is to factor, and maybe to do some other things, but at least to factor. So when I look at the numerator, I see that I can take a y out, and I've got y times the quantity y squared minus 25. Right, so there's something I could do. Now, I might think, well, I should probably do some more. When I look at this quantity right here, it's the difference, subtraction, the difference of two squares, y squared and 25, which is 5 squared, right? 25 is 5 squared. So what does that mean? Well, the difference of 2 squared, the difference of squares is two binomials that are exactly the same, but they have opposite signs inside. Right? And now, in the numerator at least, I've done all the reducing, simplifying that I can think to do. Okay, well, think about the denominator. Right? I'm going to move myself up here, and I'm going to rewrite the numerator. And that denominator, I should be able to factor into two binomials, right? I know that there's going to be a y times a y. Now there's a 2 coefficient. I can't factor that 2 out. So that really just means that there's a 2y in one of them and just a 1y in the others, because 2y times y is 2y squared, right? And we need 2y squared. Okay, now we have a plus 5. So that means that it's either a negative 5 times a positive 1 or a positive 5 times a negative 1. But it's got to be a 5 and a 1, right? Now, I don't know exactly where they go. Sorry, I just said something wrong. Let me erase that, ignore what I just said, and let me try it again. It's a positive 5. That means it's either a negative 5 times a negative 1 or a positive 5 times a positive 1, right? The signs have to be the same. Well, that tells me what sign they are. They're both negative. Now my only question is it 2y minus 5, y minus 1, or is it 2y minus 1, y minus 5, right? Does the 5 go here, or does the 5 go here? Well, I would like to think that the 5 goes here, because that matches something I have upstairs. So I'm going to try that first. Negative 1y, right, when I multiply those two. Right, so here's a negative 1y. Then when I multiply these two, what do I get? 2y times negative 5 is negative 10y. Negative 1y and negative 10y equals negative 11y. And so I was correct. We have 2y minus 1 and y minus 5. Okay? Okay, so what can I do at this point then? Do I have any factors upstairs that are the same as factors downstairs? I do. Those can cancel, reduce to 1, literally. So on top then, what I have is y times y plus 5. And downstairs, what do I have? 2y minus 1. Okay? So there I have written the original expression as a rational algebraic expression, a fraction, in lowest terms. And I've reduced that fraction. Okay? Example 2 at the top of the next page. Let me give myself some space here. Okay, example 2 at the top of the next page says this. 6 minus 6a over 5a squared minus 3a minus 2. Okay, now the instructions say simplify, right? I mean, this would be like you had 24 over 36 and it said reduce. Okay, simplify the fraction, reduce it to its lowest terms. Okay, so that's what I want to do here. All right, I want to reduce it to its lowest terms. Generally speaking, when I'm asked to simplify an algebraic fraction like this, I need to factor, right? So, you know, again, I might look at this and think, I have no idea what to do. Well, you're trying to simplify, so see if you can factor. When I look upstairs, the two terms, 6 and minus 6a, I can factor out a 6, and that leaves me with 1 minus a. Right, so I did something. Well, what about this? This is a trinomial, so trinomials, hopefully I can factor into binomials, right? There has to be an a times an a to get a squared. 5, the only way you can get 5 is 5 times 1. So I know that much. Now, with the 2, the only way you can get 2 is 2 times 1, but it's negative 2. So I'm either doing a plus 2 times a minus 1 or a minus 2 times a plus 1. Now, since this sign is negative, it tells me that the signs in the binomial are opposite. I looked at this sign here, and it tells me that the largest number gets the negative sign, right? But I have to be careful because there's a 5 that I am using to multiply. So let me just take this first possibility. And let's try 5a plus 2 here and a minus 1 here. Okay? And let's see what happens. So we're trying this first possibility. If I multiply here, 2 times a is 2a. If I multiply here, 5a times negative 1 is negative 5a, the negative sign, remember I said that this was telling me the negative sign has to go with the larger. The negative sign is with the larger. I have 2a, I owe 5a, I owe 3a, negative 3a. So there it is. That first one I tried was it. Okay, so now I factored the trinomial. I can write this as 5a plus 2 times a minus 1. So now I look at that and I say, well, there's no factors upstairs that are the same as the factors downstairs. Although that 1 minus a is really close to that a minus 1, isn't it? In fact, upstairs the 1 is positive and the a is negative. Downstairs the a is positive and the 1 is negative. If I could just reverse the signs on that factor upstairs, that 1 minus a factor upstairs, I would have the downstairs factor, wouldn't I? Well, you can do that. Whenever you need to reverse signs, all right, where you have, it's kind of the inverse. It's not really, I shouldn't use that term, but it's kind of swapped, right? The 1 minus a is swapped with the a minus 1. You can fix that by simply multiplying by negative 1. What does that do to that 1 minus a? It turns it into a minus 1. Watch, negative 1 times a is the negative a. Negative 1 times negative 1 is the positive 1. Now I have 5a plus 2 and a minus 1. This factor and this factor simplify, reduce to 1, right? And so I have a 6 times a negative 1 on top, which is a negative 6, and I have a 5a plus 2 on the bottom. Okay. This particular fraction right here, I've written as negative 6 over 5a plus 2. I could also write it as negative 6 over 5a plus 2. I could also write it as 6 over negative 5a plus 2. Notice that I was careful to put the 5a plus 2 in parentheses because it's the whole denominator that is negative. Okay? So those are my options of how I can write a fraction that is negative. I've got 3 options where I can put the negative sign. And in fact, I mean, this is probably the most common, I would suppose, assigning the negative to the term upstairs. If you were given a problem that started this way, it would be entirely legitimate to rewrite it that way if that was going to help you solve the problem. So, now in this case, a can't equal whatever is multiplied to 5 to get negative 2. I'm not sure what that is. I guess it would be negative 2/5. I guess I am sure what it is. But that's, so a, this is our solution, right? Or our simplified fraction, a not equal to negative 2/5. Okay? Now, I want you to notice that just before the written exercises on page 160, it says in bold, hereafter in this book it will be assumed that the replacement sets of the variables in a fraction include no value for which the denominator is 0. Okay? So, I think what they're saying is that at this point you don't have to worry about in your answer writing down what's not allowed, because the assumption is that if it's not allowed, it's not allowed. Okay, so there's your lesson 5-3, and you will have problems 1 through 19 odd to do, and maybe a couple other problems from previous sets to do to keep those ideas fresh in your mind.